in this situation, we have mean, median, and mode as the measures of central tendency. So in this situation, for mean, we can determine mean either for a group or on-group data. For an on-group data, where you have your numbers spreading out without designated frequency. In that situation, we are to use, so our mean, which is denoted by x bar, is the same thing as saying summation of x all over the number, which is n. But if it is for group data, that is, when you have a particular score or mark with the corresponding frequency, then we are to adopt the use of this formula. That is, x bar equals to summation of f of x over summation of f. That is for mean. So your question can come in two dimensions, either as on group data or as group data. Then for median is usually what? The middle value. That is when the numbers are arranged in order of magnitude, either in ascending order or in descending order. That means if you are given the numbers, the set of numbers scattered, the first thing, our job is to first arrange them in descending or ascending order. Then we can now pick the middle number as our median. If we have an odd number, then our median is going to be very easy for us, because if you have, let's say, 1, 2, 3 as it now, this is odd number. In this situation, we just pick 2 as our median. Now, if we have, let's say, even number like this, the first thing we need to do is that since this number has been arranged in ascending order, then we remove this and we remove the 2 extreme. By the time we remove the 2 extreme, we discover that we'll be left with 2 values. So these 2 values now, we can now add them up. By the time we add them up, that will be 5. Then we divide by 2. That will be 2.5. So in this situation now, our median in this regard will just be 2.5. That is for what? On group data. But for a group data, to determine our median, all we need to do is we have 2 ways of looking at it. It's either the number is odd or what? Even. If the number is odd, the formula to apply is this first one. That's n plus 1 over 2h. That's when n is what? Odd. The moment we discover that the set of numbers that we have is odd, then we have to adopt the use of this one. But if the number that we have is what? Even. In that situation, we have to adopt this n over 2, everything in th, then n plus 1 over 2, everything in th. Then we add them up. Then we now at the end divide by 2. That is for what? Even. Then for mode is the one with what? The highest frequency. So that means for on-group data, all we need to do is just to check the number that appear most. So the number that appears most will definitely be our mode. So in that situation, once we are given a set of values, all we need to do is to look at those values critically and fetch out the number that appear most. That will definitely be our mode for on-group data. But for a group data, we have got no other choice rather than to resort into the use of this formula. And if you have to use this formula, our interpretation of the parameters must be correct. In the first case, we know that L1 is the lower class boundary of the modal class. You know that what it means is that, let's say our class boundary is just 5 to 8 or let's say 5 to 7, for example, if we have, let's say 2 to 4, this is 1, 5 to 7, this is the second one, let's say 8 to 9, or 8 to 10. So we will just go to this class interval. We trace the one that has the highest frequency. That will definitely be what? Our modal class. Take note of that. Let's say this one is 1, this one is 2, and this one is 3. I mean the frequency. This is the class interval, and this is the frequency. So in this regard, this 3 has the highest frequency. So our class interval for that is 8 to 10. What is the lower class boundary? It will be 7.5. What is the upper class boundary here? It will be 9.5. That means you remove 0.5 from this. You remove 0.5 from this, then you add 0.5 to this rather. This one will be. Remove 0.5 from this, that's 7.5. Add 0.5 to this, that's 10.5. So automatically, the class boundary of the lower class boundary of the modal class will now be what? 7.5. That is what this N1 is standing for. Then D1. D1 is the difference in frequency between that of the what? Modal class and the class before it. Take note of that. So in this regard, if let's say we still have a continuation here, which is 11 to 13, and this one is now, let's say, 1 again. So in this situation now, if you look at this very well, if you want to determine D1 from here, because I said D1 is the difference in the frequency of the modal class and that of the one before it. So this is the modal class 3 minus the one before it will definitely be 2. So we'll just put 2 here, because this is the class before the modal class. So it will be 2, 3 minus 1, minus 2, that will definitely be 1. So that is what D1 will stand for, according to that explanation. Then D2 is the difference in frequency of the modal class and the one after it. Take note of that. So D2 in this regard, the modal class is also 3, still remain the same, minus the one after it. What's the one after it here? 1 here, and that will be 2. You can see that now. So this one is difference in the frequency of the modal class and the one before it. This one is difference in frequency of the modal class and that after it. Take note. Then lastly, this other parameter, this is what they call class width. They call it class width. Class width. So class width here, you just pick, so subtract this from this, any one of them. So let's see, 13 minus 11, that's what? 2 plus 1. So our class width here will definitely be what? 3. 3 will be our class width, because it means 11, 12, 13. That makes it 3. So our class width here is going to be 3. Take note of that. So that one I've settled measures of central tendency. That is why on this note, if you are to survive as far as measures of central tendency is concerned, you are to make sure that you memorize all these formulae which will help you. Then let's talk about measures of variation. That is another one. Measures of variation. Under the measures of variation, we have range, we have quartile, then we have percentiles. So in this situation, what is range? Range is the difference between the highest value and the lowest value. So if you are given a set of numbers, we pick the one that is the highest, we subtract the one that is the lowest from the one that is the highest, we determine that. So that one is very straightforward. Then when we now talk about quartile, quartile can be classified into 3. We have lower quartiles, we have median, then we have upper quartiles. Then every one of them has its own formula. In the case of lower quartiles, which is denoted by Q1, it is n over 4 n over 4th item, which means in the most cases where your n is the cumulative frequency. Take note of that. So in this situation, if our cumulative frequency is 100, so all we just need to do 100 over 4, because n will now be 100. N will be 100 in that regard, then 100 over 4, so 4 divided by 100, that's 25. So that will be 25th item. After we have been able to construct our OGIF, the one that is known as OGIF is when we have our cumulative frequency against the class mark or class boundary, for example. So by the time we draw our OGIF, which will be taking a shape of this kind, which we ought to have learned in our previous lessons. So then we trace the 25th to the horizontal, and I will show you an example to justify this, or to have a clearer picture of what I am talking about. Then the median is Q2. Median is Q2, and the formula is n over 2 th item. That's n over 2 item. So n over 2 item. So in this situation, since our n is 100, it will just be 100 over 20 over 2, and that will be what, 50th or 50th item. So in that situation, then we have 50th item. We can also trace that from our OGIF. Then upper quartiles. Upper quartile is designated by Q3. So in Q3 is the same thing as 3n over 4 item. And when our n is 100, it will be 3 times